Good evening everyone, my name is Earl Brian Digaranat and I'm going to show you how to plot the given scenario description, which is at 1300 the ship is on course in 225 degrees true bearing by 10 knots. With the use of visual method, the OOW observed Ague Point Lighthouse, which bears 25 degrees relative bearing. After an hour, the same object was abeam to starboard. So if we are going to plot, we need this kind of tools. We have compass divider, also the chart nav 213, and the triangle roller. So let's begin. So we're going. This is so at the description scenario, we are going to point the Ague Point Lighthouse. So the Ague Point Lighthouse is located right here. And then the given course is 225 degrees true. Then we have our 25 degrees relative bearing, so we cannot add we cannot get 25 relative bearing because that is not a true bearing. So in order for us to get the true bearing, we are going to add 225 degrees true bearing plus 225 degrees relative bearing, so we have 250 true bearing. So as you can see, I'm going to plot right now. We have we have 250. I'm going to find the 250 first. Okay, 250. We're going to the Ague Point Lighthouse. So Ague Point Lighthouse right here. I'm going to put an mark. Then next, then this is the line of position. The first plotted line position is 10:30 100 hours by 250 degrees true, because we add the relative bearing and the true bearing. Now we need to locate the ship's bearing. So it says here, so we're going to locate the ship's bearing. So as it says here, it is 225 degrees true bearing. So that is the true bearing of the ship. So 225 right here, 225 and 225 degrees by 10 knots. So we're going right here by 10 knots. So right here, we're going to put a line mark. This is as a second position, and this is the line position, which is 10:30 100 hours 10:30 100 hours with a true bearing of 225 degrees true bearing. Now we are going to calculate our distance run after the first position. Our first observation is by 10 knots. So 10 knots is equal to 10 nautical miles. So this is the given direction of the 10 nautical miles if we are going to count. So we have here 10 and we have here 20 and 30. Also we have 30, 40 nautical miles. So what we're going to do is to find, we have 10 knots. So 10 knots is equal to 10 nautical miles. So 30, we have 10 nautical miles distance. We have here 40. So I'm going to put an direction on each course. Okay. And also we are going to make a DR position. So I'm going to erase that over line. I'm going to circle it. So we're going to write DR 10 30 hundreds. And next here, it says here that, and after an hour, the same object was abeam to starboard. So the abeam to starboard is what we call, or the meaning of 90 degrees. 90 degrees to the ship's heading. So we have here the 2 to 5 degrees true bearing, and we have also the 25 degrees relative bearing. So in order for us, not in order, so we have our true bearing with the exact amount of 250 degrees true bearing. So it says here that we have a beam to starboard. The beam to starboard is we have 990 degrees true bearing. So we are here at 225 true bearing. So 225 true bearing at 90 degrees true bearing is equal to 315 true bearing. So we have right here 315 true bearing. So we have 315 degrees bearing, true bearing. So we have going to find the 300. Sorry, 315. So right here we have the line of position 315. It says here that we are going to point the Aguio Lighthouse, Aguio Point Lighthouse. Excuse me. Okay, next I'm going to slide it. So, going to point the Aguio Point Lighthouse. It's too much. So I'm going to get Aguio Point Lighthouse right here. And then we are going to make a line of position. Okay. Now this is what we call 11:30 hours by 315 degrees true, because it says here after an hour. So now we are here to transfer the LOP to the, so we have right here the first LOP. So we are going to transfer the LOP here in the DR position, the line of position of DR. So it is easy to transfer this line of position. So we're going to put this one here to have the perfect exact location. So we have the LOP position right here. And then we're going to slide right here, the position. Right here. And I'm going to make a line of position. So we have here the fixed position by 11 by, we have here the fixed position which is 11:30 hundredths. Again, we have the fixed position right here, so I'm going to put a mark cross. We have 11:30 hundred. The fixed position is right here. And then we are going to find the longitude and the latitude of the bearing. Now we're going to point here our fixed position in order for us to get the longitude and the latitude of the true bearing. So we're going to put it up here. So we have so we're going to the left, it is negative. So we have 124 degrees and 38.5 minutes. So we're going to check again. So we're going to check again. So we're going to down. We're going to find the fixed position. Then, so we have here, right here. So 40 is here, 38.5. Yes, 38.5. So we have our 124 degrees, and we have 124 degrees and 38.5 minutes. Once again, thank you so much. This is Eplan 1A. Again, this is Brian D. Garnett. Thank you for watching.